Starting. All attendees are in listen-only mode.
Well, good morning, good afternoon, everyone. Welcome to our members community meeting for December 2016. Your member community meetings are brought to you by the member committee and the communications committee. Myself, Susan Finlayside, Carl Vayette, Eric Poirier, and Claudia Cositorto. If you have any questions, if you have any suggestions for presentations for speakers, you're more than welcome to email us information at ibc-bsc.ca. We have our guest today, Mr. Daniel Barbeau. He's with the Canam Group and is currently the BIM and Detailing Services Manager. Daniel is very knowledgeable in BIM and has been even working in teaching as well. And we're pleased to have him today present on applications of BIM-enabled manufacturing, and specifically looking at the ICE District project for a new arena in Edmonton. If you're not familiar with the GoToWebinar setup, you are muted. We won't be able to hear you. If you do have a question or need to flag any issue, you can either hit the raise hand button or you can type a question or a comment into the chat window. Donc, pour notre communauté francophone, on va essayer de voir quand on pouvait faire la traduction. Sinon, on va faire, on vous encourager de rester en ligne après la présentation. Puis on va discuter qu'est-ce qui a passé en français. Puis aussi, si vous avez des questions en français, vous êtes bien à l'aise de les commander en français. So just a brief update on where we're at. Our member community continues to grow. We're over 400 members now across Canada with a few international members. And our affiliate program also continues to grow. Our affiliates are our local user groups that see the value in associating with Building Smart and making the link into our network of excellence. So supporting Building Smart Canada affiliate program is supporting BIM-BC, Calgary BIM community, Group BIM Quebec, Edmonton BIM community, and we're pleased that coming soon will be a Toronto BIM community, Atlantic BIM community, and Winnipeg BIM community. If you have any interest in being involved in any of those groups, you're welcome to contact us to get more information. And without further ado, we'd like to hand it over to Mr. Daniel Barbeau. Daniel, thank you very much for being with us today, and the platform is yours.
Yeah, thanks. So just, can you share my screen now? Okay, hold on. I'll move to my presentation. Montrer mon écran. So you can see my screen now? Still here?
Certainly.
No.
Okay.
There we go.
Perfect.
Working. So let's get going. So hi everyone. Thanks for the introduction. My name is Daniel Barbeau and I work for the Canam Group. Today I'll be talking to you about another side of BIM, which one that is a bit less sexy or glamorous than the whole big deployment and big BIM execution plan. I'll discuss about the manufacturing side of BIM, one that Canam Group has been using for many years now for our own purposes, and now we start to open up to the world and tell, look, this is what we can do using your models, and this is the advantage of sharing your model with us. So our agenda, first we'll talk to you about why we BIM, what's the incentive for Canam to use those technologies, and then I'll review each process from sales and estimation all the way to the field to show you how we leverage these models in order to make a better project management and reduce our risk on those projects. And I'll finish up with some questions. Hopefully there will be some questions. I know I talk fast. I'm a super enthusiastic person, so hopefully I'm not losing you down the road. I'll try to speak as clearly as I can. So why do we BIM? It's a good question that we'd like to ask ourselves a lot of time every year, because if we don't know why we BIM, we have no purpose of doing it. So basically, this is why we BIM. This picture should be showing you exactly why we BIM. You can see a river now, and this river is pretty quiet, pretty calm. But this is how we see BIM inside the companies. We see it as a calm river flowing with information that anyone can use at any time in order to take the best possible decision, and in order to reduce our risks. So we need a steady digital flow. So sometimes this river is using 3D support, but sometimes this river is only using information or data support. So when we talk about BIM, we emphasize on the I from BIM for information, and this data river is what we use to take our daily action. And at the end of the day, Canam mantra is giving a better customer experience. So if we can show some control and some control over this data and this documentation on the project, we surely give our customer a better customer experience, because he knows we're still in control and there's no rapid white water. So we're always navigating through a steady river. So this is the idea. Does that sound good so far?
Yeah.
Okay. So sales and estimation. Hold on, I'm having some feedback on my. Hold on. Okay. Still here, sorry for the. Okay, let's continue. So sales and estimation, whenever it's possible, we like to receive a model from the engineering firm that has worked on the design. And what do we do with these models? First, we do a model audit. So is this model good enough for estimating? Is this model good enough to start working on the job? We have prepared a little algorithm that we use to define the quality of the model, because every engineering firm has different degrees of competency using those models. So we can't just close our eyes and say, well, we're going to use it anyway. So once this is done and we realize that the model can be used, we are able to make a quick takeoff directly from the Rivet model or the Bentley model, or whatever software was used to create the model. And the goal is to go through the model and make a purchase of material as fast as we can. And this specific project, which is the Ice District Arena, the design wasn't complete, and the opening date, for stadium and arena, our ecosystem where we work most of the time, the opening date it doesn't change. There's the expression, the show must go on, then the show must go on. So we have to do whatever we need to do to open up at the right date. So being able to use the engineering model for purchase of material was a big time saver for us. Even though the design wasn't complete, we were pretty close to what we needed in terms of purchasing of raw material. And we just had to update our order, but the main members were already in production at the mill, so we were able to cut a lot of time, even though the design wasn't complete. So this is the type of thing that we can do in order to shorten schedule and make a better integration with the design firm. Some other thing that we have been doing over the years with the design firm is being able to convert their model into native fabrication or manufacturing model using coordination attributes. So whenever a division or a level or a phase is completed by the engineering firm, we don't need to wait for them to complete their structural drawings before we can shoot their model and make sure we integrate it with all the changes that occurred between version 1 and version 2. So we can start detailing the job and making the manufacturing model early on the process, even though the design is not completed. So this is something that we don't see very often, mostly based on contract issues, because the 2D drawings remains the contractual document that is the most used on the industry. But from time to time, when we are able to deal with the engineering firm directly, we're able to have them agree to share their model early on. So because whenever they're releasing the drawing, the models most of the time is done for at least a couple of weeks before that. So if we can use it and start the detailing job before that time, it's a big time saver for us. So everything we do from sales to mail order is done to save some time and to reduce the risk for us when we take the job. The other side of BIM that we use for sales and estimation is doing some animation work. We need to prove to the customers that whatever we'll be doing, we'll be in control of what we'll be doing. So over and over again, we were asked to provide them, when we pitch the job, that level of control over the job. What was an extra 10 years ago is now almost mandatory. If we don't show up with these kind of animation and these kind of knowledge about the job, we will probably be rejected from the start. So this is a big change over the years. So the first one was to show how the mechanism would work, and this one was to show how we intend to use the very small space that we had on the job site in order to make our job. So most of the time they're not they're schematic plans, but they still show our strategy in order to make the project work. So this is a good way to communicate with the customer how we're going to use the information from the engineering and how we understand it, and make sure that everybody's on the same page at the end. Because using BIM most of the time is just to make sure we are all on the same page. So that's pretty much it for the sales and estimation. I'm really making an overview right now. I'm not entering into too much detail, but if you have more questions, don't hesitate to ask them at the end. So now for project management purposes, using the model to create information-rich parametric elements is what we do on a daily basis. So I showed you a quiet river early on. But the way to achieve a quiet river is to work on the sources. Different sources are all flowing into one big river at the end, but the main one remains the 3D model. So we are sharing the mentality we all have at the inside is we need to be perfect at the source, so everyone can work with reliable information later on. So we use the model to put all the RFIs, the extras, the change orders, the status of production. So we go from the moment from when the member is inserted into the model and all the way to install at the field, and we can rely on this model to tell us exactly where we are on each pieces or on each assemblies on the job. So we can provide the customer with progress report by division, by type of member, by whatever he needs, because all this information is inserted member by member. So we can then make any type of group that we want in order to show up where we are at any given time. We also use those models. This is the ice district again. We have used the 3D model for coordinating with other sub-fabricator. Sometimes we take the package for everything that touches the seal, but other time, like for the ice district, we had to coordinate with the membrane fabricators and without any contractual. But at the end of the day, we still had an agreement with them that it would be better to coordinate using those models with or without contract, because that's the best and probably the only way to do it accurately. So we work with different software. Navisworks is one of them, but we work with different software to make sure that our models are clash-free with anything that touches our steels, because that's where the limits of our products. We work with the steel, but we also work with all the surrounding products. So we can't close our eyes because we come first and the other will adjust. We need to think about everyone that will come in just after us to install their elements. And sometimes this even goes, this applies to our own company. Canam Group works on many different steel products, and the drafting team are different from from one product to another, and for technical reason we're using different softwares to achieve the drafting. The reason is that one can't do anything, so we do part of it in Revit, we do part of it in Tekla, we do part of it in SDS2, depending on the product we're selling. But our approach is to sell all of them, if ever possible, at the same time. So we can't afford to go to the customer and have clashes between our own element on the field. This would look a little bit like a fool. We can't even coordinate our own product, so we make sure that any product is brought to Navisworks, and then making sure it's clashed before it's being produced at the different facilities that we have. So as you can see, the application are mostly internal from that side, just to make sure we deliver the best quality product at the end. Now in the shop, that's maybe the least known application, because you don't see that too often. I'd like to show you some of the application we do in the shop. This is a CNC machine, for those who doesn't know what it is. This machine has been eating our model for maybe 20 years now. And this is the main reason why steel manufacturer, we have been so involved with 3D modeling early on, like where everybody has been joining the BIM movement maybe for 5 to 10 years. Canam have been using a 3D model to feed their CNC machine for over 20 years now. So we have been lucky enough to be brought into this early on. So it's a good thing for our industry. So one application is to be able to work on those big nodes. It's not always easy to find out the best and the most economical way to build a node like this. So we use a IFC file that we export, and we put it into a BIM site, so we can make a quick animation to show in which order the shop personnel should install each element. So the drafting team just produce the BIM site model, and then the shop itself is able to work with the file and create the animation one piece by piece to make sure that it's assembled in the right order, and that we save as many shop hours as we can. We also use the laser scanning in order to do some quality control. Some project that we work on are the assemblies are so complex that using the traditional tool, we can't even make sure that the elements have been fabricated according to the requirements and within the tolerance. So the shop guys were basically telling us, well, I think it's good, but I can tell you for sure. So hopefully it's good. So when we reach that conclusion, we decided to include some laser scanning within our own shop. So where most of the people are using laser scanning to acquire existing condition, we use it to verify that the model has been not the model, but the assembly has been produced exactly as per the theoretical model. So basically we scan, then we clean up the model, we clean up the point clouds, and then we overlap the point cloud over the theoretical model, and we give a color gradient in order to show the delta between the points and the theoretical model. So that helps us find out where the models are not exactly aligned with what it should be. So there is some limits to this process. So one of them is cambering, or maybe some elements that are not very rigid. We have a hard time making sure that we don't have false positive, meaning that the piece has been scanned one way, but it was in that condition in the shop because it was not, let's say, fully supported. So the point cloud is a bit distorted, and then we raise a flag. But at the end, there was no production mistake. So we're still experiencing with the best way to use those technologies. There's some very good application. There are others that are maybe less interesting, but we'll pursue our research on these technical tools. And our St. Gideon shop is looking to have some like a permanent scanner installed, so to make sure we scan as many as we can. Another challenge with this technology is the fabrication process is a two-step process. Once first you assemble the element together with just a small weld between them, and then you actually produce the full weld. But at each stage, the best scenario would be to scan what first after the welding, the fitting, to make sure that all the elements has been placed perfectly. And the other one would be after welding, because after welding there still can be some distortion due to overheating. That happens all the time. The reality is we work on a very tight schedule, just in time. We don't really have the time to work with both. To scan twice, so we just happen to scan whenever it's possible, and that causes some problem over the course of the project. Okay. One other application is, like I told you, if we have a great river, we can use it for many purposes. One of them is to plan how we're going to transport the elements from the shop to the job site, using the 3D model and knowing exactly where's the center of gravity and what's the volume that the old steel occupies in the space. It helps us plan which flatbed is going to be used, and then whenever we need to go out for permits, providing the different government with these kind of diagrams is like a no-brainer for them. Well, these guys knows what they're talking about, because they're actually showing me in 3D exactly how the elements will be put on the truck. So that helps us a lot. One more thing that we do is the moment the 3D model is completed, we know exactly the size of each assemblies. So we can the transportation or logistic team can challenge the engineering team regarding well, this assemblies cannot be transported. So before that, most of the time we had to wait until the shop drawings were fully completed to realize that this specific assemblies was cannot be transported from point A to point B for a different reason, whether it's too heavy or too large, or it requires an escort. So using those models and leveraging it early on the project helps us make the best possible assembly and really save on transportation. Now another example from the ice district, we had to transport all the steel with train freight. This helped us save a lot of money, so we used the 3D model in order to plan the loading of each of these containers to make sure it's as efficient as possible, and it's using the most space that is allowed to us to transport it. So this is one very good example of how we can use the BIM and the information regarding the members in a 3D world, right? Now, in the field, some example again, site logistic and 4D planning. From time to time, or let's say more and more, we're being a director on the job we fabricate. So being able to use some simulation, crane simulation, to plan where and when each crane will be moved, where it's going to be at what specific time, where are we going to place the steel on the job site, really helps us save time and money on the job site, because it's not a random thing that just happens. We try to plan it as best as we can. The downside of this process is we haven't been able to automate it. So whenever the schedule is changing, so in a very an ever-changing scheduled project, we have a hard time adjusting this model in a dynamic way. We need to do that manually, and it's very time-consuming. For other projects where there's very few schedule change or design change, we are able to do that early on the project and then define our best possible schedule, so the field actually is driving the need for production, and we know exactly in which order each piece will be produced, and when it's going to be shipped, and where it's going to be dropped on the field exactly, and where the crane should be at that specific day, and if it's not, why isn't the crane at the specific place at that time. So this is something very useful that we've been using over the years. So Still imperfect though. Still a lot of work to be done on that side, but we're confident that we can add some automation in the future. We also produce some weight reports, so being able to give the shop personal with very precise information about each assemblies. It's for the same reason that the shop guys wants to know how to assemble it. The erection personal wants to know exactly what is each assemblies and how it's going to be loaded the best way. So how do we assemble 3 of them on the floor? How much? How it's going to weigh? How heavy it's going to be? So where do I pick them? Where's the center of gravity? So this is all information that is like gold for the erection team, and we try to provide them that precise information as much as we can. Now, regarding sharing, I was asked to talk a little bit about how we use open format in our daily activities. So basically, we're able to share, and we're willing to share our model because we believe it's the most accurate model. We reach level 400 for those who are familiar with LOD level. So being able to share this precise information with every other team on the job site and every other actor on the project, we believe it's very interesting. So what we actually do is we were able to make an automatic publication. Some of the jobs we work on are like a 10 to 15 different Tekla model for the production of the shop drawings. So we are able to automate this publication. So it's weekly, and it all ends up in Navisworks or in IFC format, depending on the needs. The interesting fact about this model is it includes all the sources. When I'm talking about the sources, we've been talking a little bit about the Tekla model, but the other sources we're using are P6 for the schedule. We're using our manufacturing software for production follow-up. We're using SharePoint for document control. So all of these platform are sources that are all linked together in that federated model that we can provide the project team automatically every week. So if you look at the right side, each member on the model has all its history. What's the order number? What's when was it fabricated? When was it shipped? Who did it? Who did whatever? So we have a very high traceability over each assemblies on the job. So whoever needs some information on the member, they know exactly when it's due on the job site, when it's going to be fabricated, whatever. All this information coming from various sources are all linked together into one place. So it's very useful not only for our project team, but also for the general contractor and the designer to know exactly what's the status of each piece. So when it's time to decide whether or not they're actually working on a design change, they don't need to call us and ask us, well, what's the status of your production, because they know with maybe a couple of days behind, so they know pretty much where we are and where we'll be in 1 week or 2 weeks from now. So I cannot say this is a perfect process. It's still ongoing. It's still being polished because the various sources uses different data sets that we need to all align, so it's all end up in a perfect way at the end. There's other small stuff like field work, field repair that we need to include also in those models. So the model we give to the customer at the end really reflects exactly what happened, not only in a 3D aspect, but also in its history. So all the data attached to the members are really telling the truth about this member. So this is what we're trying to push as much as possible. So basically, if the client wants it IFC, we can do it IFC. If he wants it Navisworks, so we're really open to provide it on the platform that is required by their customers or by the other actors. On some projects, we've been publishing this model on 4 or 5 different platforms. I have to say it was not very efficient, but then there was no unique platform that was defined by the customers at the end. So everybody was trying to pull the blanket on their side. We were just like, okay, you want it that way, let's do it that way. So we tried to facilitate the sharing of this information. Once again, coming back to this river that we want to be as smooth as possible, not only from the inside, but also for our collaborator on the project. So that concludes my presentation. I hope you learned some interesting, cool fact about how we really leverage the BIM and the 3D models to create some better quality steel construction job. So from this point on, I'm willing to take any of your questions. Hopefully you find it interesting.
Thank you, Daniel.
Yeah, thank you very much, Daniel. So, are there any questions? Y a-t-il des questions de la part du monde? Une question ici. I have one question here. Very interesting. So, great comments around the interest. I would have one around tracking tracking the progress within the model. So you link to Primavera. So are you you're linking the status? Where are you tracking the status? Is it in Primavera at the module level, or do you do that somewhere else?
We do it somewhere else. We do it in our own database, something we've built over the year. And then we from that database we can publish it on any platform. So basically, our company made the decision not to be tied to any of the integration platform, commercial platform on the industry. We want to be independent on this side. It doesn't mean we don't want to use them. We want to use whatever platform. We just want to reduce the risk that is happening when you put all your information on one platform that from any day can be let go by the software company. So basically, we extract all the information from the different sources. So the geometrical information and from the model, the scheduling information from P6, the production information from our manufacturing software. So whatever is used is all gathered into one spot, and it can be viewed using something that we call the Canam Collaboration Center. This is how it works internally. Does it answer the question? So no, basically all the information is not pushed back inside the model. We could do it, but we found out that it's going to be useless, because most of the time the tracking doesn't need to be done in 3D. We just need to be done in 2D, and if ever needed, we can still move it back to the 3D federated model if needed, to understand why and which part is owned by which information.
So I guess the responsibility of tracking piece by piece and updating the status, is that distributed across the team, or is it with the project manager or project coordinator that does that and tracks each piece along its?
It's a good question, and we see that differently. Each bit of information is owned by a different group, right? So the schedule information is owned by the project control team. The production information is owned by the shop. The detailing status is owned by the detailing team, and the project management overlooks all of this to make sure that like a chef d'orchestre, I don't know the word in English, I'm sorry, but like a captain, to make sure that all the different teams internally are working on the right priority at the right time. So we basically, each information has an owner. Does that answer the question?
Yeah, that makes sense. There's questions here from the people in attendance. One of them is, during the model audit, does the price of the detailing services that you guys provide change depending on how advanced the engineering model is? So I guess the question is, if you have a very advanced model that's high quality, does that change anything on your end in terms of detailing and production?
Yeah, it sure changes the allowance we put on the job, because the less the less assumption we make, the more precise the bid is. And we try to team up with engineering team as much as possible, so we can provide the price early on based on their design. But yes, the more completed it is the model, the more precise is our, and the most competitive our pricing is. This is how it works.
Another question here around how does the model assists you in your business intelligence and customer relationship management? Are you tracking, which customers you're providing what, and linking that into what you produce?
Not too sure what is the question. Which customer information do you think should be put back in the model? I'm not sure I got the question right.
So the model, the question is, how does BIM assist your steel packages in relation to business intelligence and customer relationship management? I guess I don't know if maybe Alan, if you wanted to perhaps.
Well, we use some metrics to evaluate each customer that can be done. Then we do that mostly on the type of project. This type of project, this is the number of member we get. This is the tonnage of steel we get from these type of member. This is the number of hour we get, and all that based on the model. But customer specific, it's very hard because one customer can work on different type of job, and he's not really he does not control how many R5s there will be or whatever. But yeah, this is all information that is there that we could use to make some better business move on the future. That's a fact, right? But it's not always our customers' fault if the job's going wrong, right? Sometimes it goes beyond their control, because we mostly work for GCs, and if the design has been done too fast, then it's not the GC's fault if there's a lot of coordination involved. There's not a direct correlation between this customer and the fact that all of his projects are bad, right?
Mm-hmm. There's a question here around, so your work seems to illustrate that BIM is most valuable to you due to its flexibility, supporting many engineering business processes. In your opinion, does this mean that the BIM side of the technology is already there for most industry needs? The challenge is more about leveraging it in a firm's practice.
Yes, it is, and the fact that we've been on this for 20 years, we had plenty of time before it was actually named BIM to define what we can do using those models, what type of reports. So we were not even realizing that we were doing BIM. So I believe that doing it is not doing it is not because of the technology not being ready. It's there, and it might not be perfect in every way, but then it's better than doing it using an Excel spreadsheet and a paper and a pen, right? So sometimes it's a lot of people, the moment they stumble on something not working, they just say, well, it's not working, so let's keep doing it the old way. But it's an iterative process that evolves over time, and it's on us to make it evolve as well. If we're just saying it's not working, then it's never going to work. If we do it and make the best out of the technology that are available, then it's still working and it's still helping us. Do we do everything using this? No. Are we pushing to do everything using BIM? Yes, that's our goal, right?
That's excellent. So I don't know if there are any other questions from the yes, there's one here. Are there specific IFC attributes you require from the engineering firm to enter in their 3D structural model in your BIM execution plan? And is this specified in the contract to avoid duplicate data entry?
Depending on who we work for, if we work for the owner directly, then we can ask for specific attributes. The one that comes to my mind are status. Tell me where you are. Is it completed? Is it being held? Is it because and this can be very useful for us to start working only on the members or on the elements that has been finalized by the engineering firm. So status is one. the loading is another one. If we can use the actual exact loads that has been used by the engineering, so we can use it to create our connection design. So most of the time, the engineering don't put the exact load of each connection. They just put a general note that says, well, you have to design it for 50% of the deflection capacity of the member. So if we can have this information, we can make a much better design, and if whatever it's changing, we can shoot the model and make sure that all the loads that has changed due to a redesign or a changes requested by the customer, so we know exactly that these 4 or these 10 connections will be affected. 9 out of 10 remains the same, and then the 10th one we need to add a bolt. So this is the type of analysis that can be done when this type of information is included. Now, do we have a lot of control over what's inside the BIM execution plan? Not a lot, because most of the time we bid the job when it's in the bid phase for the GC. So we try to push as much as possible to move up that chain, because we believe that the sooner we are involved as one of the main contractor or subcontractor on the job, the better we can help optimize the design and reduce time spent by engineering doing some drawing, because they can actually share their 3D model efficiently. So let's say that in the ideal world, we receive 3D model with some information in it, like loading and status, and we receive some directive that are like Excel or whatever Word directive, and we can produce the structural drawing from the manufacturing model. This is stuff we have done over the years, so it cuts down the time spent on drafting some permit and spending more time on the design. So, but it's all related to the project structures, and we don't have much control over this.
Danielle, I do have a question for you to wrap up, if there aren't any other questions.
Yeah, go ahead.
Yeah, you had mentioned that the amount of work in standards development for interoperability within the steel industry has been decades. Right now, you're presenting for Building Smart. You're familiar with the organization and what it does. From your perspective, in terms of standards development, where do you see a gap in the offerings or areas that should be focused on to alleviate any difficulties that are still current?
I don't know. Standard from our perspective, if there could be some mandatory or recommended ways of putting information in the engineering model, then that would make our model audit, no matter when we do it, whether it's during the design phase or when in the bid phase. If the model is still at the right parameter, then we can make some standard auditing tool instead of readjusting it from project to project, because each project being different and modeled differently. So this is, from my point of view, how Building Smart should address the fact that these structural engineering models should and have to be used for manufacturing afterwards, whether it's concrete or steel. There's ways to make it happen, so let's just try to define it as best as we can, right?
Right. Thank you. Well, on behalf of our member community, I'd like to thank you for your presentation. Very well received. Definitely, you've already reached out to us to say to all the members, if they would like more information, they're welcome to contact you. They can also use the email address on the screen at the moment, information@ibc-bsc.ca. Similarly, if anyone's interested in a recording of the presentation, if you have colleagues that would benefit from seeing the presentation, we can make that available to you through this email address. So thank you, Danielle. Really appreciate your presentation. Next month, in January, in the new year, our next meeting is scheduled for January the 25th. same time, same place. We will be hosting Rob Jackson of Bon Brian Digital in the UK. He's quite the advocate for open standards, interoperability, one of the lead BIM, I guess, communicators out of the UK and deployers of BIM. So quite a lot of interesting experience and opinions on his part that he's going to come and share with us, specifically around Building Smart's agenda for interoperability and open standards. So we invite you to join us then. You can stay tuned to that through our monthly newsletters. What we have planned for the 2017 year is to continue bringing you both local Canadian presentations as well as leaders in the international sphere of BIM and open standards. So kicking that off will be Rob, and then the following in February we'll have a Canadian presentation. So thank you very much. We do encourage you to submit presentation requests to the email provided. Speaker requests could be topics. If there are presentations that we've done that you've really enjoyed and found them to be a lot more informative than others, we also enjoy having that feedback. It helps us to plan ahead. So thanks very much. Thank you again, Danielle and Eric, for hosting as well. And thanks, Claudia, as well, for being online. Have a good day, everyone. Bye.